449? 449 is a piece of cake now compared to 446, right? So what's it look like? Well, we've got that beam that's kind of a, if you will, inverted L shape. Sorry about that. Let's get that a little bit better. What do you think?
Yeah.
Okay, so let's just.
This coming Monday, right?
That's correct.
Monday and Friday.
Monday and Friday. Why can't that? Why does that not go away? Okay, so up here we've got BY. This is point B. We've got a BY. It's not. It is pinned there, right? BX. Then we've got a force here we're going to have to deal with. We've got AY. AX we know is 0 because it's on a roller. There's one of our answers already done for us. Talk about a piece of cake. You got to get that one right. Okay. Then we've got a 12 kip force out here. We know that is 5 feet to the center of that. And that's all connected there. Well, then we've got this force right here is actually what? 2 kips per foot times 4 feet. The feet cancel out and you're left with kips, and then you have to divide that by 2 because it's a triangle, right? So you end up with 4 kips. The overall height of this thing was 4, right? 4 feet. So we need to find out what's going on here. And the triangle was done something like this, right? So that means that this is 1/3 times, so it's 4 divided by 3. So 1.33 feet from here to there, which means this is 2.66, right, or 2.67 feet. All right. Remember, I told you if it's on a vertical axis, it doesn't really matter. It's still, you know, you could tilt that and it'd still be the same way, but it has to be 1/3 of the way from the leg of the triangle, the vertical leg. So that's all we need to know, isn't it? So we'll do a sum of the forces in the X. So we got BX over there going to the right minus 4 kips. That's it, isn't it? Therefore, BX, this goes to the other side of the equation, becomes positive. 4 kips. It was positive. We said BX was going to the right. Since it's a positive value, it is going to the right. Okay, so now we got 2 answers right. 2 out of 4, not bad so far, 50%. Well, that is kind of bad, isn't it? If you only had a 50%. So we got to work on getting better. So we'll do our sum of the forces in the Y. Yeah, if you had a bad grade on that first test, this quiz would really be nice to come up with a really good grade. Okay, and it's a lot of the same stuff. Actually, this, in my view, is maybe even easier. You don't have so much trigonometry. That's what I like to call it. Well, let's see what we got. We got AY going up, minus 12 kips, plus BY, right? If you could see the picture. two unknowns. So we have to go and do a moment, and I'm back to point A again. Now, I guess you could argue it might be better to use B in this case. See that? If you use point A, if you use this as your moment, you have this force, that force, and that force, right? If you do it about point B, you get rid of Bx and By, which we know Bx equals 4 kips. But you still get rid of, we don't know By. You still get rid of 2 forces there by doing it at B, as opposed to 1. But see, always in all the other problems, A was always the pinned part, wasn't it? So I guess the concept there is take your moment from the pinned position, because then you don't have to deal with 2 of those forces. I did it at A, but now it hits me when I look at that, it's like, well, dumbass, why don't you do it at point B? So you get rid of 2 things. I already know Bx, but I still have to put it in my equation. See? So let's do it at point B. We're going to deal with this 4 kip force here, this 12 kip force here, and that AY, which is what we're looking to solve for anyway, isn't it? So we'll do a sum moment at B. So we said we had that 4 kip force. Now that 4 kip force, when you're looking at that relative to B, that thing is trying to go and spin. It's trying to take off. Let's see, come on, cursor. Trying to take off and go this way, right? Which is clockwise, which is negative. This force right here, relative to B, is trying to make this thing go this way, right? Which is counterclockwise, so it's positive. This one's trying to make this thing go that way, which is negative. Doesn't matter what the shape of that thing is. That's what, if you only had it pinned at B, that's what it would spin that way, wouldn't it? Wouldn't matter if I was a fish hook or just a straight piece of line. That's what would happen. Okay? So it's a neat little problem too. So we'll go in there. Whoa, got carried away. So let's see, we had the 4 kips, and we said that was making it go clockwise, which is negative, right? And it is 2.67 feet from point B, right? According to our drawing. Right there. The 12 kips is 5 feet from B, isn't it? And that's going counterclockwise, so it's positive. Plus 12 kips. I forgot to put my kips in there on that 4. At 5 feet. Minus AY. And it's actually 10 feet, isn't it? From B. Okay? It's the perpendicular distance, right? So if this force were, that transmissibility, it was up here and it's perpendicular to this way, that's the distance you're looking for, right? Okay? So we only have one unknown now, so we can solve for that. So if we put AY on the other side of the equation, it's going to be, well, let's see now. Yeah. So it's going to be, I hate to do that, but this is negative. Let's just do, it's 12 kips times 5 feet minus 4 kips times 2.67 feet. All of that divided by 10 feet. If you punch that into your calculator, I hope it comes out to something like 4.93.
Okay.
Did I leave something out?
No.
Okay. 4.9 or 4.93 kips. Sorry, I said feet, didn't I? Is that what you had pause with? It comes out a positive value, right? Which means that AY was going up. So now we're batting 75%. Now we can just take that and substitute that back in up here at the y equation. 4.93 kips. BY stays where it's at. Everything else switches to the other side. So 12 minus 4.93 it should be 7.07 kips. Came out positive. We said BY was going up. So it is. So what I was telling you about the moment at A, if we were to look at that, here's what you would have to have for the moment at A. This is why I said do it at the pin location. It's probably easier. And this is what I had done originally. It was minus 12 kips times 5 feet plus 4 kips times 1.33. Okay, those are the two you would have had, right? Or let's see, yeah. Then you would have had minus 4 kips, which is BX, times 4 feet. See, that's the one we didn't have to deal with because we went through B, plus BY at 10 feet. And if you do the math on that, then BY still equals 7.07 kips. Okay?
The 4 kips at 4 feet, wouldn't that be positive? And they can go counterclockwise?
No. The moment at
4 feet.
if you look right, so if you look at that, we're doing it relative to point A, right? So if this is, here's point A right here, and this force right here, if you brought it up, well, it is going, it's going negative, right?
Yeah.
Okay. Anything else? Yeah, I kind of felt like it was good to show what those. You just have to deal with more if you do it at that location. See, we got 50 and 51. Hopefully, we can get done here.